Good morning, everybody. So, myself, I am Bhushan, Controller of Examinations and Associate Professor in EC Department at Laxman Reddy Institute of Technology and Management, Dundigal. Today, I am here to introduce the course Electronic Measurements and Instrumentation. So, I'll be just overviewing about the course objectives and the course outcomes of this course. So, coming to the course objectives of the course, the students will be able to learn about the studying about the functioning of the various performance characteristics of the measuring systems, and also able to know about the basic functioning and the working principle of the signal generators and the signal analyzers. And the students able to learn and understand about the oscilloscopes and various types of the bridges, and they'll be able to also learn about the concepts related to various transducers and also the measuring of the physical parameters, and develop various virtual instrumentations for specific applications, and also to study about the biomedical signal. These are the course objectives of the course Electronic Measurements and Instrumentation. At the end of the course, the student will able to understand what the course outcomes of this course, which are the first course outcome has to be study the various measuring systems and performance characteristics of the devices, and the course outcome to select the signal generators and how to use, way to use that he'll be able to learn in various types of applications. In course outcome 3, the student will able to analyze the functioning and operation of the special purpose oscilloscopes such as dual beam oscilloscope, dual trace oscilloscopes, and sampling oscilloscope, digital storage oscilloscopes, and also try to measure the physical parameters in bridge applications for AC bridge and DC bridges. And also the course outcome 4 tells about the significance of the transducers in measuring various applications of the signals. And last, the course outcome 5 will create about the vertical instrumentation applications like which are used in the control system, signal processing and image processing, etc., and also study about the biomedical signals. Now, I'll be worrying about the syllabus of the 5 units in this electronic measurements and instrumentation course. So, coming to the unit number 1, it deals about the various characteristics of the system, such as static and dynamic characteristics of the measuring systems. So here we'll be knowing about what do you mean by accuracy, what do you mean by precision, which do not vary with respect to time, which come under static characteristics, and also the dynamic characteristics which depends on the time. So this is what we'll be looking into the unit 1 course, where we'll be dealing various problems related to accuracy and precision. And coming to unit number 2, so we'll be seeing about what are the different types of signal generators that are used to generate varieties of signals, such as sinusoidal signal, ramp signal, sawtooth signal, pulse signal, rectangular signal, and also checking and also seeing about different types of signal analyzers such as AF analyzer, HF analyzer, harmonic distortion analyzer, and that we'll be seeing in unit number 2. Coming to unit number 3, we'll be seeing about what is an oscilloscope, what do you mean by special purpose oscilloscopes, which are meant for using for different types of applications, which are like dual beam oscilloscope, dual trace oscilloscope, sampling oscilloscope, digital storage oscilloscope, and also seeing about different types of the bridges, Wheatstone bridge, Kelvin's bridge, Maxwell's bridge, sharing bridge, and everything that we'll be seeing in unit number 3. And in unit number 4, we'll be looking into the transducer and its classification of the transducers. So transducer means like it is a device which converts one form of the energy into another form of energy. And also we'll be looking into the different measurements of the physical parameters, such as how do we identify or measure the humidity and the moisture. And unit number 5 comprises of virtual instrumentation and about the biomedical signals. So before getting into the course, we shall see what are the prerequisites that are essentially required for the students to have good knowledge in order to learn this course. First of all, the students have to have a good mathematical background, the physical background, the physics background, and they should have a good knowledge on the subjects already studied of the basic electrical engineering and basic electronics engineering. So let us get into the unit 1 topics. So unit 1 topics covers what do you mean by measurement, what do you mean by an error, and what are the different blocks of measuring systems, what do you mean by static characteristics and everything. So first of all, we shall get into what do you mean by measurement and its errors. So we'll be seeing about the introduction to the measurement and instrumentation in and we'll be seeing about what are the blocks or the elements that exist in the measuring systems. And after looking at each and every block of the elements and its functioning, we'll look at the performance characteristics of the measuring systems. Then we'll see the types of the performance characteristics which are classified or categorized as two characteristics, which are static and dynamic characteristics. Then later we'll be seeing, based on these characteristics, what are the types of errors that can be seen in the performance characteristics. So measurement. So what do you mean by a measurement? If you basically see in general, if I want to measure the height of a human being, generally we check with the tape or something like. So similarly, in terms of the measuring system, the measurement tells the property of something that is to be measured. Okay. So measurement is a process by which one physical phenomena will be converted into meaningful numbers. Okay, if you can see clearly, for example, the watch that we wear, that will give you some measurement that is with respect to time. The rulers, the scales will give you particular measurement. Okay, so these are few of the examples where the measurements can be done with the help of the instruments such as rulers, the stopwatches. The stopwatches are essentially that are used in the games which try to know the time of exactly it started and ended. And the thermometer is one of the device which tells you about the measurement of the temperature purpose, and the weighing machines will tell you about the weight of the particular human beings. Okay, especially in engineering, measurement is a process or an act or a result of comparison between a known and unknown quantity. So this is what we'll be doing. For example, you can see here, if you want to take some material, so I need to put some known weight, 1 kg example, and the other item should be on the unknown item where we will be placing in this. Okay, we see the general block diagram of a measuring system. It consists of basically 4 elements. So one is the measurand, the other is the transducer, the next is the signal conditioning, and the last is the outcome or the result or the display that is being recorded. So measurand, what do you mean by measurand? The parameter to be measured, that parameter to be measured is called as the measurand. Okay, so this measurand is the input to any measuring system, example force, example pressure, example the current or the voltage that we give to the system, that is called the measurand. So next is the transducer. So this transducer will convert one parameter into another parameter, or one form of energy into another form of energy. So after converting one form of energy to another form of energy, then that is being given to the element called a signal conditioning element. So this signal conditioning will do some process such as signal manipulation, signal transmission and everything. And then after that, whatever the value that is being measured, that is being recorded using a recorders or from displaying device. This is the basic or the general purpose measuring system that we can look into that. So basically the measurement contains two things in the result, whatever that we there. So one is the unit of the measurement. For example, if we take any solid items, that we generally try to measure in kgs. If we take any liquid elements, that we try to measure in liters. If we take any gas, cubic meter, like that. Okay, so basically a result of any measurement has two components. One is the unit of the measurement, another is the number. For example, if we consider weight of a human being, where if I consider it as 65 kgs, so in the 65 kgs, the number is 65 and the unit of measurement is done in kgs. This is the example of the components of the measurement. And the measurement methods are of two types. One is the direct method, we use directly to measure it, or the indirect method. These are the components of the measurement. Next, coming to the generalized block diagram of the measuring system, basically the input, the basic input that we give it to the first element is the primary sensing element. So the name itself says it senses the type of the input that is given to that block. Okay, so this primary sensing element will take the input, which can be either voltage or the current. It senses it and then it gives to the variable conversion element. So as the name itself says, this this block will convert one parameter into the another parameter. So variable conversion element. Then that parameter at the output of the variable conversion element is given to the variable manipulation element. Here the manipulation in the sense some modifications or corrections can be done on the given value that is given as the input to that. So after manipulating the element, some modifications which are done to that parameter, it has to be transmitted. So that job is done through data transmission element. This data transmission element, whatever the data which is in forms of zeros and ones, that is for that is to be saved for future purpose with the help of a data storage element. So with the help of this data storage element, which is nothing but the memories, the examples of the data storage is the memories where the data is stored in the memories. Then again this after the memory, this data is again given to the data presentation element where the data is being presented and the observer will note the readings from the data presentation element. So if you look at this generalized block diagram element from the input stage to the output stage, clearly all the basic functions are very much required to convert the process from the input side to the output side. So this is about the generalized block diagram of the measuring systems. So as I just now discussed, the basic element, the block elements of the measuring systems are the primary sensing element, the variable conversion element, the variable manipulation element, the data transmission element, the data storage element, which is an optional in the block diagram, and last is the data presentation element. This is about the basic block diagram of the measuring system for any system that we take. Then next is the next topic is the performance characteristics of the measuring system. So generally, what do you mean by the performance characteristics of the measuring system? The characteristics of the measuring instruments which are helpful to know its performance in measuring any quantity or any parameter or any function, that it's called as the performance characteristics. These performance characteristics are basically classified into two types. One is the static characteristics, the other is the dynamic characteristics. So in detail we look it into that, what are static characteristics and what are dynamic characteristics. So coming to the static characteristics, static means which do not change with respect to time. So any parameter which will not vary with respect to time or do not change with respect to time is called as static characteristics, right? So we'll look at and what are the different types of static characteristics that are used in the measuring system. Okay, the first one is accuracy. The second parameter of the static characteristics is the precision, resolution, and few other types are sensitivity, linearity, reproducibility, tolerance, bias, hysteresis, zero drift, dead space, range. So these are the parameters or the characteristics which comes under static characteristics. And coming to the dynamic characteristics. So dynamic means the parameters which vary with respect to time. So any parameter which have variation with respect to time is called as dynamic characteristics. Under dynamic characteristics we have four types. The first one is the speed of response. What do you mean by speed of response? How fast the system is responding for a particular input, that is called as speed of response. Fidelity means for a given input we are getting some output. So this output should be with respect to the input without any deviation. Faithful reproduction of the input at the output, we call it as the fidelity. Then measuring lag. Lag is nothing but the difference between for some delay. The measuring lag is nothing but the delay that is being produced at the output. The delay basically it will be in nanoseconds. Dynamic error. So error is nothing but the basic difference between the measured value and input value, but this should be with respect to time. So error is nothing but for a particular system there is an input, there is an output. So output minus input. So if that output minus input there is some variation between the output and the input, that we call it as a error. But in the dynamic error it has to vary with respect to time. That is what called as dynamic error. That's what all about the unit 1 introduction part. Coming to the unit 2 topics. So we have the introduction to signal generators. So and signal analyzers also. So basically signal generators, the name itself says, a device which can able to generate varieties of signals, that we call it as the signal generators. So basically signal can be mathematically represented as a cos omega t plus 5, so which clearly the parameter says the amplitude, the frequency and the phase angle. Okay, so the purpose of using the signal generators, they are especially used for testing the purpose. So whether a particular circuit or a particular instrument it's working or not, that can be done with the help of the signal generator. In even designing the electronic circuits and systems also, we use the signal generators. So the basic signals that are generated are sine wave, square wave, triangular wave and any arbiter wave that can be listed out. So types of signal generators. So basically types of signal generator, depending on the frequency range, they are classified as the audio frequency AF, the audio frequency range, RF, HF signal generators. And apart from that, we also have the function generators. Function generators where clearly a particular function is selected and it will be displayed at the CRO part. So they are standard signals. In function generator, basically we have sine wave, we have ramp wave and we also have the square wave. Those are the basic functions which are there in the function generators. And coming to the pulse generators, it produces the pulses with respect to the specific widths and amplitudes. Basically the pulse generators are used for all the digital circuit testing purposes. So the next type of the signal generator is the RF, which works in the operating frequency of 30 to 300 megahertz. So this is the operating frequency range which is used for RF frequency range, and these are used for the testing communication devices. So audio signal frequencies, or which are also called as AF signal generators, which operates in 20 hertz to 20 kilohertz. Especially this is used for the sound testing purpose. So apart from this, we also have sweep generators. Sweep generators means which is nothing but the FM, the frequency modulation. It sweeps over a particular frequency and is used for the frequency response analysis. So here we can see few instruments, how does they look like, few examples of the signal generator. The function generator, this is the latest model of the function generator which are used in the digital display values, and this is one model of a signal generator, and this is the other model of the RF signal generator and audio signal generator. These are the few examples of the signal generators. Next, coming to the signal analyzers part. So introduction to signal analyzers. So the main itself says analyzer, analyzing a signal. What do you mean by analyzing a signal? Which can able to measure the relative amplitudes of a particular complex signal that at a particular frequency. That is called as the signal analyzers. Okay, so for what purpose we use these signal analyzers? In order to evaluate the signal quality, in order to find where exactly the distortion is occurred, that we try to look at into the signal analyzers part. Okay, so depending on the frequency also, the signal analyzer are classified as AF signal analyzer, HF signal analyzer, RF signal analyzer. And apart from the frequency ranges, we also have spectrum analyzer, where everything operates in frequencies. Okay, so it is amplitude versus frequency. So we'll try to find the measurement with respect to amplitude versus frequency. So it displays the power across the frequencies, and especially it is used for identifying the interference and harmonics. We also have the network analyzers, logic analyzers, power analyzers. These are few of the examples which comes under signal analyzers. So coming to the application part of the signal analyzers. So all the communication systems, basically a communication system is nothing but a transmitter and a receiver. So in order to test these transmitters and the receivers, we require signal analyzers. And in order to analyze the modulation techniques such as AM, FM, PEM, and all the remaining other techniques, we use the signal analyzers. And especially we also use the signal analyzers in the circuit design part, especially the debugging and the verification circuit functionality. In the audio systems, we use the signal analyzers in order to evaluate the sound quality that is being done. In order to test the microphones and the speakers, also we use the signal analyzers. RF systems, especially testing of the antenna, that way that we use, and also all the education purpose we use. And here you can see few examples of signal generators, how they look like: the spectrum analyzers, harmonic distortion analyzer, and the logic analyzer part. So coming to the unit 3 overview, it is basically oscilloscope. So what is an oscilloscope? Basically, oscilloscope is nothing but, I can call it as an voltmeter, because it displays the signal's value amplitude in terms of voltage. So it is a test instrument which can see the values visually. All the signals, all the varying signals, all the AC signals can be seen visually. That job can be done with the help of the oscilloscope. Okay, for all the electronics, if the signals inputs are AC signals, then the output can be clearly seen in an oscilloscope, how the signals are being varied and everything. So this is how a basic block diagram, the basic view of an oscilloscope, how does it looks like. So all the circuits, if we want to know the output in form of graphically, then we use the oscilloscope either at each and every input and the output part. And we also have the special purpose oscilloscope, such as the different purpose, which are for digital storage oscilloscope, mixed signals oscilloscope, sampling oscilloscopes also are available, which are used for specific purposes. And coming to the bridges, the bridges are the electrical circuits which are used to measure the RLC components. So in any circuit, bridge is nothing but which has 4 arms. 3 arms will be known, the other arm will be the unknown arm. So the unknown arm, we try to measure the unknown resistance, unknown capacitance, unknown inductance, and unknown impedances. So basically, bridges are classified as 2 types. One is AC bridges, the other is the DC bridges. So DC bridges. So DC means the input source is DC. The input source is DC. Okay, so that to a bridge, if the input is DC, that is called as DC, and if the input source is AC, that is called as a AC bridge. Okay, so the basically the most basic bridge is Wheatstone bridge that you find in the DC bridges. And coming to the AC bridges, in the DC bridges, we try to measure only resistance. Whereas in AC bridges, we try to measure, apart from resistance, we try to measure the inductance, the capacitances, impedances, the frequencies. Apart from that, we also try to measure the parameter called as reactances. Then we try to find the crest factor, power factors, the loss factor. These all also can be measured with the help of AC bridges. So if I just look at the comparison between AC and the DC bridges, the signal type that is being given is the direct current for the DC bridges, and whereas for alternating current for the AC bridges. So as we discussed just now, the quantities that can be measured for DC is purely resistor. It is used for only purely resistance purposes. But whereas for DC, we can measure the remaining components such as inductance, capacitance, the frequencies, impedances, and everything. So the basic types of the DC and AC bridges are Wheatstone and Kelvin. And whereas for AC, we have Maxwell, Schering, Wayne, and the remaining other. We also have Anderson bridge. These are few examples of AC bridges. Coming to the application part, we try to the DC bridges are basically used for measuring resistance. Under that, we can measure low resistance, high resistance, very low resistance also. And for AC bridges, basically used for measuring high resistance and for its analysis part. So coming to the virtual instrumentation part, the virtual instrumentation is a software-based approach which is used to design and implement the measurement and the control systems. Basically, it is the purpose of it is used for the computers and the modular hardware, which can be flexible for the software to replace the tradition and standalone instruments. Like basically, we use the oscilloscopes, the multimeter, and the signal analyzers. So if you look at the key components of the virtual instrumentation. So we need to have a general purpose computer where the central processing unit is used for data acquisition analysis and also the presentation analysis. Typically, it includes the power processor, memory and the storage. This is related to the hardware, which is the computer. Coming to the software part, it also has it is a combination of both hardware and the software. So in coming to the software part, the core of the virtual instrumentation is used for the customization and it is user interface design. So the popular softwares that can be used is one type is LabVIEW, which is by National Instruments. So it is the graphical programming environment. We also have the other softwares which are MATLAB and also which is the part Simulink, which is part of it. We also have Python with all the libraries and everything. These are the software platforms that can be used for the virtual instrumentation. Coming to the biomedical instrumentation, it is refers to the design and the development and the use of the devices which are used to monitor, measure and analyze the biomedical signals for diagnostic purpose and for research purposes also. So few of the biomedical signals examples are ECG, electro, elec, ECG, electrocardiogram. Basically, study of the heart, the functioning of that is called as ECG. It is called the ECG signal. It will clearly measure the monitors about the heart's electrical activity. EEG, electroencephalogram, it completely monitors about the brain, the study of the brain waves. MRI, magnetic resonance imaging, it is in the detailed images of the soft tissues. So this is about today's AMI course objectives and the outcomes. Thank you very much.